Good evening. In this video, we are going to work out one of the organic chemistry questions extracted from 2013 Science Paper 3. This is the question that we are going to work out together. Below is a list of some organic compounds represented by the letters A to E. Give the name of a compound A. So in this case, we have a list of compounds that are presented by capital letters A to E, and we are asked to name compound A. So to name compound A, you should remember that organic compounds are named according to their number of carbon atoms that they have and also their functional group. So looking at the question that we are asked here, it has got only one carbon atom. Therefore, one carbon atom, the name will begin with meth. If it had two carbon atoms, then the name will start with eth. So in this case, the name of this particular compound, it is going to start with meth. Then the ending part, now we look at the functional group of that particular compound, or we look at the functional group of its family name. So in this case, the family name of this compound is alkane. So it is going to end with the ANE. So meaning the full name of this particular compound, we are going to combine the prefix and also the suffix. Therefore, the final name will be called methane. So this compound is methane. Coming to B, identify the two compounds from the list that belong to the same homologous series. So here you should first understand what this word homologous series means. The meaning of homologous series is simply members of the same family that have the same functional group. That is what it means. So we are asked to identify two compounds here that are coming from the same family. So to do that, you are going to compare these compounds so that whatever compounds that will have the same functionalities or same properties, then those compounds are coming from the same family. So now we'll start with E. When you look at E here, E is ending with COOH, that is COOH. And when you try to relate this or compare this to other compounds that are given here, there is no other compound that is ending with the same COOH. Therefore, E is disqualified. Coming to C, C here is ending with OH. And when you also try to compare this to other compounds that are here, we do not have any other compound having or ending with OH. Therefore, C is also disqualified. Then we have A, B, and D. These are quite challenging. We cannot guess using our eyes. So therefore, we are going to run through some of the homologous series properties. So some of them are here. Properties of homologous series. One, they have the same general formula. That is very true. Compounds that are coming from the same homologous series, they have the same functional group. Coming to 2 there, they have similar chemical properties. That is also very true. As long as compounds are coming from the same homologous series, meaning they have the same chemical properties. Coming to the last one there, they differ from the next consecutive member by 1 carbon and 2 hydrogen atoms. That is very correct, and that is the one that we are going to use in order to determine the two compounds here coming from the same homologous series. So C and E are disqualified. So we have A, B, and D. So we are going to start with A since A is the starting point. A has one carbon atom. So the next one now will differ from A by one carbon and two hydrogen atoms. So for us to get the next one, meaning we are going to add one carbon to A and two hydrogen atom to A so that we get the next one. To get the other one, we are going to do the same so that we get, when you look at B and D, the number of carbon atoms are 4. So let's do that. So we are starting with that one, the first one there. Then we are going to add one carbon atom and two hydrogen atoms. When we add those, we are going to have two hydrogen carbon, two atoms of carbon, and then 6 atoms of hydrogen. So we are going to add until we get the 4 hydrogen, the 4 carbon atoms. So we'll add the same because they differ just by this. So therefore, we are going to add 2 hydrogen atoms, 2 carbon atoms there, plus 1 carbon atom in red. It will give us 3 carbon atoms. Then the 6 hydrogen atoms plus the 2 hydrogen atoms will get C3 and H8, meaning 3 carbon atoms and 8 hydrogen atoms. Then we need to have 4 carbon atoms because B and D, they have 4. So we are going to add with the same because they differ only by this. Therefore, when we add, we are going to have 4 carbon atoms and 10 hydrogen atoms, like that. Therefore, when you check properly here, A and B are matching. A and B are following this rule, but D, it is not following this rule. When you add this, it is not giving us 4 carbon atoms and 8 hydrogen atom. Therefore, the answer now will be A and B. So A and B are coming from the same group because they are following this rule, which they say they differ from the next consecutive member by 1 carbon atom and 2 hydrogen atoms. Coming to C. C, there are 3 questions that we are going to work out together. The first one, state the compound which has the same functional group as ethanol. So they want us to determine which compound that is listed here has the same functional group as ethanol. So when you look at ethanol, just from the name, ethanol is an alcohol. And the functional group of alcohol is hydroxyl, meaning they contain the OH in their formula. So meaning alcohol contain hydroxyl, which is the OH group of atoms. So you are going to check out in these compounds here, which compound there is ending with the OH or has the OH. So the answer there, class, it is C. So C is also alcohol because of the hydroxyl which is there. Coming to 2, draw the displayed molecular structure of ethanol. So here we are told to draw the structure of ethanol. So just from the word eth, it means that it has got 2 carbon atoms. So you are going to draw first the backbone of carbon atoms. So as long as you know already that it has got 2 carbon atoms, then you are going to draw a ring like this. So that is your 3 carbon atoms. Then you are going now to distribute the hydrogen atoms to each carbon atom and make sure that each carbon atom there acquires an octet row, meaning it should have 8 electrons surrounded. So meaning each line there, it is carrying 2 electrons. So meaning if it has 4 lines surrounded to it, meaning it has got 8 electrons. That is what we've done. So meaning, since this is an alcohol, we are going to distribute all the hydrogen except one. One, it is the one which is going to possess the OH. So it is going to look like that. We are going to distribute hydrogen, 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 hydrogen. Then the last one now, or anyone, should have the OH. So this OH, it can be up there, it can be anywhere, as long as there's one bond having the hydroxyl, because that is the functional group of alcohol. Coming to 3. Construct a chemical equation for the hydration of ethene to form ethanol. Remember, ethanol is an alcohol, and alcohol is prepared by 2 methods. One, it is by fermentation, the common one that we know. And then the other one is by adding water, or rather steam, to ethene. When you add steam to ethene, we produce what we are calling alcohol. So you're going to react when we say hydration, meaning you are adding water to ethene so that you form what? Alcohol. So now you're going to write the formula of ethene plus water, which will give us now the ethanol. So here is the equation, how it is going to look like. Coming to D. D, we have 2 questions. Give one compound that is unsaturated hydrocarbon from the list above. So from here, you need to understand that the meaning of the word unsaturated hydrocarbon. What is unsaturated hydrocarbon? So whenever you hear about unsaturated hydrocarbon, we mean a hydrocarbon that contains at least one carbon to carbon double bond. That is what it means by unsaturated hydrocarbon. So meaning there's a carbon to carbon double bond. At least there's one. If not one, there can be many. But here now in our case, at least there's one carbon to carbon double bond. Then that one will be qualified to be unsaturated hydrocarbon. So now they want us to give a list here. They want us to name which one here from this list that is the unsaturated hydrocarbon. So as usual, C and E, we are going to disqualify this because this is an alcohol. Alcohol, they don't have a double bond. And then the E also, these are other family members. Of course, they do, but these, they are usually not unsaturated. So now we are going to concentrate much on A, B, and also D. So now how do we determine that? Maybe we are going to use a long way here to see how we can determine which one is unsaturated by simply drawing their structure. That is what we are going to do. So we'll start with A. A has one carbon atom. So we are going to draw one carbon atom and also distribute the hydrogen surrounding that hydrogen carbon. Make sure that the hydrogen, the carbon atom, it is bonded to 4 hydrogen atoms. So that is my structure there. That is carbon ring, and then we have 4 bonds connecting the 4 hydrogen atoms, meaning it is going to be like that. So when you look at this, it is balanced. The carbon, it has got 8 electrons there. Each bond, remember I said, there are 2 electrons there. So 2, 2, 4, 2 there, 6, 2 there, 8, meaning carbon is balanced. Hydrogen should have 2 electrons, and there's one line there connecting to hydrogen, and there are 2 electrons there. So hydrogen is also balanced. Therefore, this compound is not unsaturated because there is no single bond. There is no carbon to carbon double bond. And by the way, there's only single carbon there, so no carbon to carbon double bond. Therefore, A is also disqualified. We go to B. How many carbon atoms are in B? So remember, there are 4. So the first thing that you should do is you draw first the ring structure of carbon, or a carbon backbone. So that is what you are going to do. That is a carbon backbone that you've written. Then how many hydrogen atoms are there? There are 5. So make sure there are 10. So make sure you distribute those 10 hydrogen atoms. Make sure you share them equally, and you have to make sure that each carbon atom is balancing, is having 8 electrons. Remember, one line, it means that there are 2 electrons there. So that is what we are going to do. So when you look at my lines, there are 5, there are 10, and my hydrogen atoms are 10. So I mean it is going to be like that. And when you check them clearly, each carbon there has 8 electrons. Therefore, this particular compound here, it is not, it is saturated. It is not unsaturated because it contains single bonds. Coming to the second one, which is D. D also have 4 carbon atoms. So you are going to draw the structure, the carbon backbone. So that is my carbon backbone. And then don't worry about the up arrows there, because I've counted the number of hydrogens which are there. I only have 8. No wonder I have lines, these lines that will connect hydrogen being 8. 1, 2, 3. The first one has 3. The second one has 2. The third one has 1. And then the last one has 2. So, meaning we have 1, 2, 3, 4, 5, 6, 7, 8, because of the number of hydrogen atoms that I have. No wonder I have not put up there, because I have only 8 hydrogen atoms. You don't have to add, you don't have also to subtract. So now, when you distribute your hydrogen atoms, it will look like that. So when you check clearly, the first carbon atoms, when you check it well, it is surrounded by 4 lines. It means that it is balanced. It has acquired an octet rule, or rather it has got 8 electrons. So meaning that one is stable. When you come to the second carbon atom there, when you count the number of lines connecting to it, there are also 4. That means it is also stable. But when you look at the third one has only 3. When you look at also the fourth one, the last one there, it also have 3, meaning these 2 carbon atoms, they are not balanced. Therefore, you don't need to include other hydrogen atoms there, no, because the number of hydrogen atoms, there are only 8. So please don't add or subtract. Therefore, you are going to introduce a double bond between these 2 unbalanced carbons. So meaning you are going to add another bond like that. So therefore, when you count now, they are balanced. This one, the third one has 4 lines. The last one also has 4 lines. Therefore, this compound is saturated because it contains a carbon to carbon double bond. So the answer there is D. The answer there is D. Coming to D2, describe a chemical test for unsaturated hydrocarbon. So now when you are testing for unsaturated hydrocarbon, we add bromine. We add bromine to unsaturated hydrocarbon. Bromine, it is in brown color. So when you add it to unsaturated hydrocarbon, bromine changes its color from browny to colorless. So it turns orange, brown, bromine solution to colorless. So here now, bromine, they are saying it is in orange. Bromine, it is orange. Sometimes we say brown, but orange, according to my notes here. So it turns orange bromine solution to colorless. So as long as the compound is unsaturated, when you add bromine to it, it changes colorless. Coming to E, compound E is acidic. We are told compound E is acidic. State the name of the compound E. As usual, organic compounds are named according to how many carbon they contain and which functional group they possess. This is the rule that we are going to follow. So, if the compound contains two carbon atoms, meaning the name will begin with eth. So in this case, E, when you were to count, it has two carbon atoms. Therefore, the name of this particular compound, it is going to start with eth. Therefore, what is its functional group? So now we are told that it is acidic. Therefore, it is carboxylic. It will fall under carboxylic acid. So the ending part, it will be OIC. Therefore, I'm going to introduce another technique that we are going to answer this question. We are going to use the anoic. So we are going to get the prefix, which is eth. We are going to add, instead of adding OIC, we are going to add ANOIC. Therefore, the name of this particular compound is going to be ethanoic acid. So that's the name there. Ethanoic acid. That is the name of compound E. Now, describe a test to show that compound E is acidic. Remember, to determine whether the compound is acidic, we use what we call a blue litmus paper. So when you get a blue litmus paper, you dip it in that compound. Then that blue litmus paper changes color to red. That is how we test whether the compound or solution is acidic. So it turns blue litmus paper red. Thank you so much for watching.